Assalamualaikum and hello, my name is Muhammad Zarfan Bahman Nazir. I'm from Group 4 and in this video I'm going to explain about our methodology to validate our data. So the software that we use in this study is Ansys. Ansys is a finite element modeling tool that may be used to solve a wide range of mechanical problems numerically. So in this situation, we are going to solve in vibration analysis. So in Ansys, we are going to make a mesh, which is the mesh is a generate model of the dryer and also the washing machine stacking on each other. So in order for us to generate the mesh, first we need to have the parameter, which is the first parameter that we should have is its volume. So from this volume we are going to get the dimension. Okay, so the equation that we are going to use for calculating the volume is rho equals to m over v. So rho is equals to density of the structural steel, which is 7,850 kg per meter cube, and mass is the mass of our model, and v is the volume of the model. So we are going to use this equation, and the first mass is 98 kg, second mass is 59 kg. While we are going to get a volume. So from the volume we can extract it and turn it into dimension. So we can directly change the volume into x is because we make the model simplified, which is just cube. So a cube has equal dimension, which is its length, height is all the same. So for this situation we are just going to use the cube, so it's going to generate our mesh much more easier, and also it is much more easier for us to calculate our data. So this is the parameter that we must know, which is model 1, m1, m2, mass, volume and side length. Next, I'm going to explain on how we are going to get the data from this Ansys. First, you have to open Workbench Ansys, and then we are going to go to engineering data. In this engineering data, we can set the density of the material that we use, which is structural steel, which is just the default of Ansys. Then after we set the engineering data, we can go to geometry. From this geometry, we are going to generate mesh. So this is the mesh that we are going to use. So from this mesh, we are going to open it in model. So in this model, we are going to add spring to the generate mesh figure. So in this study, we have two design, which is design 1 and design 2. So the first step in this model, we are going to add spring to the generated mesh figure. Spring 1 and spring 2. Spring 1 will be body to the body, and spring 2 will be body to the ground. Next, after that, we are going to set the parameter of the spring, which is of course for design 1, the k is different, and for design 2, the k is also different. So we need to set the parameter according to our k. So next, we are going to move on to the model. So here is set model. So in this model, we are going to add remote displacement. So there are two remote displacement that we need to add, which is the remote displacement 1 is for mass 1 and the remote displacement 2 is for mass 2. So what does remote displacement do is that it makes our model move in just one particular axis. So for this model, we are going to make it only move up and down. So from here we can know that the model can go between y axis only, which is up and down. And the other parameter, which is in this remote displacement, we are going to set it to 0. So from that, we are going to solve in model, and then we can get a solution in A6. Next, we have come to our final results that we want to know from these simulations. So as you can see, as we can compare, there is not much difference between metric installation methods and using simulation through Ansys. So this is our results for design 1, and this is our result for design 2. So that's all for me. Thank you very much for lending your ear.